Assalamualaikum warahmatullahi wabarakatuh. Madam Ruby here. I think I need to shorten our workshop video because it's almost 3 hours there. This is a part of a summary from that workshop. In this lesson, we need to draw organic structure and name them according to IUPAC nomenclature. IUPAC is the International Union of Pure and Applied Chemistry, where we establish a standard way of naming the compounds in order to facilitate communication. So every scientist in the world would be naming one compound according to the same correct way. The basis of IUPAC nomenclature is that firstly, you need to find the longest chain of carbons, and then you need to find the substituents attached to the longest chain. These substituents are called prefixes or suffixes. And then the longest chain, we name them parent or suffix. Alkanes and cycloalkenes are connected by single bonds only. If they are a straight linear chain, we call it acyclic, but if it's in rings, we call it cyclic or alicyclic. The names of alkanes and cycloalkenes are the root names of all organic compounds. Here are they. I'm sure you are familiar with methane, ethane, propane, and butane, having 4 carbons. But look at the condensed structure over here. There's only 3 carbons. Why is that so? Because there are actually 2 carbons inside the bracket here. CH2 is simplified by putting a bracket and a subscript 2 after the bracket. So as all the other compounds, pentane, hexane, heptane, octane, nonane, and decane. Here are the structures of cyclopropane, cyclobutane, cyclopentane, cyclohexane, cycloheptane, and cyclooctane. Before we go further, we need to know the priorities for the substituents and functional group. They are group A, B, and C. In group A, we have 5 groups. The highest priority would be for carboxylic acid, which have the parent name oic acid. The second is aldehyde, and then ketone. Both aldehyde and ketone is a carbonyl compound. When it becomes parent, it becomes ethanol or propanol. And then the next one would be alcohol, and the lowest priority for group A would be amine. For group B, we have only 2 groups, which is alkene and alkyne, indicated by their unsaturated covalent bonds. For group C, we have several compounds: alkyl, alkoxy, this is ether, halogen. We also have nitro, cyano, vinyl, allyl, phenol, and benzene. Notice and differentiate the difference between phenol, a benzene ring, and benzyl, has a CH2 after the benzene ring.
Now I'm going to show you how to remember some shapes of alkyl groups. Okay, maybe not all, okay, but some of it have a shape, very unique shape, okay, that can help you to remember, okay, the name of it. Okay, so let's start. So I want you to refer to table 4.15 in page 139. Okay, so for CH3, you just have to remember it is methyl, 1 carbon, ethyl, 3 carbons, propyl, ethyl, 2 carbons, propyl, 3 carbons, isopropyl. How to remember? Okay, so if we have parent chain, okay, parent chain here, the longest carbon chain, okay, and we have the substituent isopropyl, we have 3 carbons in it. Okay, so the 3 carbons position will be like this. Okay, and if you look at the shape, it is actually like V. Okay, so when you come across any structure with a shape like this is isopropyl. Okay, so if it is butyl, but 4 carbons. Okay, tadi just now met 1 carbon, et is 2 carbons, prop 3 carbons, isopropyl 3 carbons, but with the shape of V, like that. Okay, this will help you to draw also. Okay, next we have isobutyl. But here means 4 carbons. Okay, isopropyl, prop 3 carbons. Okay, so how to remember isobutyl? Okay, isobutyl, still iso. Okay, let's say we have a parent chain. Okay, and the parent chain is attached to an isobutyl. So isobutyl has 4 carbons. The space here actually quite small. Okay, so I have to draw like this. Okay, so we have what structure? We will have Y structure. Okay, Y structure, but with only 1 leg of the Y. Okay, Y satu kaki je, satu je, C. Okay, next we have still sec, still but. Okay, still in but 4 carbons, but now we have sec butyl. Okay, what does it mean by sec butyl? Okay, to make it easier for you to remember, sec butyl, okay, the parent chain is attached to the second carbon in the substituent. Okay, second carbon, 1, 2, 3, 4. This is not for the numbering for naming. Okay, I just want to show that this is the second carbon in the substituent. That's why we call it sec butyl. Alright. Next, still under butyl, we have third butyl. Okay, third butyl. Okay, how to remember third butyl? Okay, third butyl. Let's say we have a parent chain. Okay, it is attached to carbon, 4 carbons. Okay, and the shape here is like the shape of capital T. Okay, so capital T shape is third butyl. Okay, next, pentyl. So straight line, straight chain, pentyl, 5 carbons. Isopentyl, isopentyl. Okay, iso. If you refer back to the isopropyl, isobutyl, the structure is actually similar. Okay, we have parent chain. Okay, and then we can have this shape. Okay, 1, 2, 3. Oh no, not enough. Should be 1, 2, 3. Should be longer. Okay, 4, 5. Parent chain. Maybe we need some space for the next drawing, so I'll draw like here. Okay, so the parent chain is attached to 1, 2, 3, 4, 5 carbons. Okay, what can you see about the shape? You can see that the shape is like Y, but longer leg. Okay, it has 1, 2 leg compared to isobutyl, only 1 C in the leg. Okay, dekat kaki Y tu ada 2 C. Okay, so panjang sikit kaki dia. Okay, next is still pent, 5 carbons, but now we have neopentil. Okay, so how to remember neopentil? Very easy. We have a parent chain. Okay, we have carbon attached to carbon, attached to carbon, attached to carbon, attached to carbon. 5 carbons. Okay, and the shape is like small t. Okay, so Neopentil. So this is how we remember some shapes of alkyl groups, which act as the substituents.
These are the steps for you to take in order to name organic compounds. Step 1 is finding the longest continuous carbon chain. Step 2 is you have to number the chain in the direction such that the position number of the first substituent is the smaller number. Step 3, we have to determine the name and the position number of each of the substituent. And then, step 4, we need to indicate the number of identical groups by di, tri, tetra, and so on. And finally, we place the position and numbers and names of the substituent groups in alphabetical order before the parent name.
Okay, let's go to practice 4.9, page 140, 141. Okay, you can refer to page 140 for the steps for naming substituted alkenes and cycloalkenes, step number 1 and until step number 5. Okay, so I'm not going to read the step for you. You can read it by your own. Okay, so the first step is to find the longest continuous carbon chain. Okay, you can start anywhere. Okay, but make sure it is the longest carbon chain. Okay, so let's say we count. Okay, from left, 1, 2, 3, 4, 5, 6, 7. Okay, if we go straight, if we go up, we will have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we choose the 8. We choose 8. Okay, as the longest carbon chain. Okay, but where to start carbon number 1? Okay, when you want to put the numbering, okay, you have to consider, okay, the carbon must be carbon that attached to the substituent must have the lowest carbon number. Okay, so if we start from above, let's say we start from here. Okay, the substituents will get, okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you will get the combination of substituent number as, okay, 4, okay, for ethyl, 4, and then we will have 5, okay, for methyls, okay, and then we have 6 and Cl at carbon number 7. Okay, but if we start, let's say I choose, okay, different color now. If we start from below, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the substituents number will be carbon number at carbon number 2, carbon number 3, carbon number 4, carbon number 4, carbon number 5. Is it correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 substituents. Okay, so if we total up these numbers, okay, so 2 plus 3 is 5 plus 4 plus 4 plus 5, it will be 18. Okay, okay, but the one above will be equals to 27. So we will not choose the blue one, okay, because that will give a larger number to the substituents. Okay, so we'll choose the purple. Okay, so I will erase the blue numbers. Okay, so that's our numbering. Okay, so let's go to the substituents. What substituents that we have? Okay, we have at carbon number 2 we have chloro. Okay, at carbon number 3 we have bromo. Okay, carbon number 4 we have methyl. Okay, and we have 2 methyl here, both at carbon number 4. And at carbon number 5 we have ethyl. Okay, now let's give the name. Okay, parent chain will be octane. Okay, because we have 8 carbons. Okay, so in giving name you have to follow alphabetical order. Okay, so we will start with bromo position first. Okay, so we give the position to the Br. So Br is at carbon number 3. So 3 bromo. Okay, 3 bromo, and then we go to C, chloro, 2 chloro, and then we go to EOM, E, should be E. Okay, it will be 5 ethyl. Okay, and then we have methyl, 2 methyls at carbon number 4. So next, 4 dimethyl. Okay, and then you just have to continue with the parent chain. Name, it will be octane. So no space between dimethyl and octane. So the name is 3 bromo, 2 chloro, 5 ethyl, 4 dimethyl octane. Okay, when we have number, after a number there is words, we put dash. Okay, if after a number is a number, we put comma. Okay, and there will be no space between the name of the substituent and the parent. So that's the answer for number 1. For number 2, okay, we have to choose the longest carbon chain first. Okay, so maybe it is we can start from right, 1 2 3 sorry 3 4, okay, 5 6. Okay, we will get 6 carbons there. But if we go up 4 5 6 7, so we have 7 carbons. So that one will be the longest carbon chain, and the parent name is heptane. Okay, so what are the substituents that we have? Here we have methyl. I should use the different color. We have methyl, we have fluoro, we have, what is this? Look at the previous video. This is called isopropyl. Okay, we have 3 carbons, 1 2 3 in the substituent, and the shape is like V. Okay, isopropyl. So the name of this compound is, okay, let's give name. Okay, very easy. Okay, the name is, okay, alphabetical order, we start with fluoro. Okay, we start with fluoro, and then isopropyl, the I is not included in the alphabetical order. Okay, isopropyl, sorry, you can refer to isopropyl is include, I for isopropyl is included in the naming, in the alphabetical order. Okay, I'm sorry. Okay, so the name will be 3-fluoro. Okay, and then I before M. So isopropyl is at carbon number 4. For isopropyl, and then 2-methyl. The name is quite long, so I have to continue below. Heptane. Okay, now let's go to the next example. Here we have, okay, which one will be the parent? Is it the one that we circle? As I said just now, the circle one is the substituent. Okay, but if you come across question like this, okay, to know which one is the parent, you have to count the number of carbon. So right here we have 1 2 3 4. Okay, but in the ring we have 1 2 3 4 5 6 carbons. So greater number of carbon in the ring, so the ring will be the parent. Okay, so the substituent that we have is nitro, and what is this? Okay, we have four carbons, and the parent is attached to carbon number 2. Therefore, this is sec-butyl. Okay, so if you refer to step 5 in page 140, sec, you just have to ignore the S. So you just consider the butyl, B. Okay, sec, S for sec. Okay, we ignore in alphabetizing. Okay, meaning it is not included in the alphabetical order of our name. Okay, so give name to this compound. Okay, we have nitro at carbon number 3. We have sec-butyl at carbon number 1. Okay, why I put 1 as attached to sec-butyl? Why not nitro carbon number 1? Because as I said just now, we have to follow alphabetical order. Okay, so sec-butyl will come first. Okay, we consider the B in butyl. Okay, not the sec, not the S. Okay, so the name of this compound is 1 sec-butyl, 3 nitro, cyclohexane. Okay, now let's go to the last one. For example, 4.9. Okay, actually we have been given the hint here. The longest carbon chain is start from where? Left or right? We start from right. 1, 2, 3, 4, 5, 6, 7. 7 carbons in the longest carbon chain. Okay, so we have methyl. Okay, substituents, we have methyl, 3 methyls. We also have here propyl. Okay, so let's give the name. What is the name? Okay, the methyl, we have 3 methyls at carbon number 2, 3 and 5. Okay, carbon number 2, 3 and 5. So the name is, okay, for number 4, maybe I should write here. Okay, for number 4, okay, the name is, okay, M and P. M comes first. Okay, so the name is 2, 3, 5. Okay, we have 3 methyl, trimethyl, and then 4 propyl. Now don't be too excited to use isopropyl or other than that. Okay, this is propyl because this is straight. Okay, and we have 7 carbons in the longest carbon chain. The parent name is heptane. Okay, so it's actually similar with how you write your name. Okay, it must be your name and then your father's name. Okay, but in naming the organic compound, no space. Okay, no space between the between your name and your father's name, your parents' name. Okay, so actually it's like this. Okay, we have substituent and parent chain. Okay, and usually no space between substituent and parent name. Okay, but make sure you state the positions of all the substituents.
When we are doing the naming for alkenes, we need to number the chain of carbons that includes the double bond, so that the double bond or restriction carbon has a lower position number. And then we have to change A and E to E and E because it's an alkene. How do we name cis and trans? When we have 2 identical groups are attached on the same side, we name them cis. On the opposite side of the double bond, it is a trans.
Alright, practice 4.10, naming molecules containing functional groups from group B, suffix only. So this is for alkenes example. Okay, so let's do it now. Okay, for number 1, okay, if you see something in the bracket like this, maybe it's quite difficult for you to give name. So open up the structure. So we have CH3, CH2, CH, double bond, CH, CH2 3 means we repeat CH2 3 times. And then attach to CH3. Okay, now let's give the number to the carbons. Okay, so the position of carbon number 1 must be near the nearest to the C double bond C, because that is the functional group, okay, in our question. Okay, so we should start from the left. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have double bond at carbon number 3. So you take the number of the starting point of the C double bond C. So it is carbon number 3. The first number for C carbon C double bond C. Okay, so the name will be 3-octene. Very easy. Okay, maybe you will be confused why madam said very easy. It is very easy. Okay, so next let's draw. Okay, expand a little bit of the structure. So we have CH3, CH3, CH3 2 means we have 2 CH3. This. Okay, so which one will be carbon number 1? Is it from the left or from the right? Okay, make sure C double bond C get the lowest number. Okay, and then the methyl, the substituent, also must get the lowest number. So we start from left. 1, 2, 3, 4. Okay, so we have methyl here. This is methyl at carbon number 2. So the name will be 2-methyl, and then we put the position of the double bond 2-butene, or you can also name it as 2-methyl but 2-ene. Up to you which one that you want to choose. Okay, let's go to number 3. We open up the structure, so it becomes like this. Okay, now let's give the number. Remember, functional group must get the lowest number. Okay, functional group here is the C double bond C. So we start from left. 1, 2, 3, 4, 5, 6. There are 2 methyls as substituents at carbon number 2 and carbon number 5. Okay, so for question 3, okay, we give name it as 2, 5. Okay, give the number, the name of the substituent first. Okay, we have 2 methyl, so it becomes dimethyl. Okay, 2, 5 dimethyl, and then position of the double bond 2. Okay, we have 6 carbon hexene. Okay, next question 4. Okay, no need to expand this structure anymore because it is a straight chain. Okay, we give number 1, 2, 3, 4. So what is the name? Okay. Right here we have 2 double bonds. Okay, 2 double bonds. Okay, therefore the name will be diene. Okay, but what is the name? Okay, we have 4 carbons, so the name will be but. Okay, but, and then refer to the position of the double bond. Start with carbon number 1 and start with carbon number 3. 1, 3 diene. Simple, right? Okay, now let's go to number 5. Okay, we should start from left to give lowest number to the C double bond C. So this is carbon number 1, 2, 3, 4, 5, 6, 7. So we have 7 carbons. Okay, so for question number 5, what is the name? 3 double bonds in the structure, so the name will be triene. Okay, so we state the 7 carbons first. Okay, we have hept. Okay, the position of the double bond, 1, 3, 5. Hep 1, 3, 5. Try in. I know you are still trying. Okay, so now let's go to number 6. Number 6. Okay, we cannot choose this part as the parent because we have only 2 carbons here. Therefore, this will be the substituent called ethyl. Okay, and the parent will be here, which is the cyclopentene. Okay, so which one is carbon number 1 in cyclopentene? Okay, in cyclopentene, we should give the lowest number to the substituent.
Okay, for this compound, the longest chain is cyclohexene. As you can see here, it has 6 carbon. It is an alkene having a double bond. So we need to have the carbon chain as carbon number 1 here, and then number 2 here, and number 3. At carbon number 3, we have an ethyl. At carbon number 5, we have an isopropyl. So it becomes 3-ethyl, 5-isopropyl cyclohexene. The restricted carbon must be in the middle of carbon number 1 and 2, and then substituent must have the smallest number. If we go the other way around, it would be a bigger or larger number. Now, example number 8 is an example of a cis and trans isomerism or geometrical isomerism. Since the Cl is on the same side, we name this molecule as cis 1,2-dimethylethene, and when it is on the opposite side, we call it trans 1,2-dimethylethene. In naming the molecules containing functional groups from group A, we need to use the highest priority functional group as the parent or suffix. Here are the modified steps for naming compounds that has the highest priority functional group. First, we name the longest continuous chain with the parent name, and then we number the chain, and then we design the position of the multiple bond and the substituent, if any. After that, we arrange the substituent according to alphabetical order, and we name the parent as the one that has highest priority functional group.
Now practice 4.11. Okay, these are the compounds or molecules containing functional groups from group A, prefix or suffix. Okay, you can refer to page 142 for the steps of naming. Okay, so let's give name now. Okay, remember you have to refer to table of functional group. Okay, table group A. Okay, page 137 to know the priority of the functional groups. Okay, so now number 1, amines. Okay, the prefix no suffix amine. Substituents on nitrogen denoted by N. Okay, let's give name to amines. Alright, we have to give number. Okay, lowest number to the carbon that is nearest to the functional group. So functional group that we have here is NH2. So this carbon will be carbon number 1, carbon number 2, carbon number 3. Okay, so the name of this compound is propanamine. Okay, propane, 3 carbons. Propanamine. Just like that. Okay, B. Okay, we have NH2. Okay, and we have OCH3. OCH3, okay, if we refer to group A, okay, it is not one of the priority group. Okay, so OCH3 will be the substituent. Okay, we call this as methoxy. If you have 2 carbons, it is called ethoxy. 3 carbons, propoxy, and so on. Okay, now we have only 1 carbon, methoxy. Okay, and this is the parent, okay, which is cyclohexane. Okay, not cyclohexane, it should be cyclohexanamine. Okay, because the parent now is the NH2 and the cyclohexane structure. Okay, so we have carbon number 1 right here, because parent must have the lowest number. Okay, and we cannot go down here for number 2, 3, 4 until we get carbon number 5 for methoxy, because methoxy must get the lowest number. So it must be 1, 2, 3, 4, 5, 6. Okay, so what is the name? The name is 3-methoxy. 3-methoxy cyclohexanamine. Yes, no space between cyclo and hexanamine, no space between methoxy and cyclohexanamine. Okay, just continue all of that. Alright, now we go to C. Okay, for C, we have 2 carbon chains. Okay, 2 carbon chain. Okay, we have the chain with 3 carbons and 2 carbons. So choose the longest one to become the parent. Okay, so this will be carbon number 1, carbon number 2, carbon number 3. Ethyl here attached to N. Okay, so the name will be, okay, we have to put the name of the substituent first. N, okay, ethyl attached to N, N-ethyl. Okay, 3 carbons, propanamine. Okay, next we have ethyl. Okay, 2 carbons. This is also ethyl. Okay, so these 2 will not be the parent. Okay, so this one will be the parent. 1, 2, 3, 4 carbons in the parent chain. Okay, so the name will be, okay, we have 2 ethyl attached to N. Okay, the longest carbon chain is 4. Okay, so the name will be N diethyl butanamine. Okay, so why we put NN? Because, okay, the substituents, okay, is attached to N. Okay, not attached to carbon. So if the substituent attached to carbon, we put numbers. Okay, but if the substituent attached to N, we put N. Okay, as the numbering for the substituent. Okay, now let's go to alcohol. Okay, for the alcohol, okay, A, we have 1, 2. Okay, always start carbon number 1 that is nearest to the functional group. Okay, so we have OH, okay, at carbon number 1. So this is ethanol. Very simple. Ethanol. Okay. Okay. B. What is B? Okay, so we have double bond. We have the OH. Okay, if we start from right, it will be 1, 2, 3, 4. Okay, OH will be at carbon number 3. But the priority now is the OH, which is the alcohol. Okay, C double bond C has no priority. Therefore, your numbering should be start from left. 1, 2, 3, 4. Okay, so what is the name? Okay, we have double bond C double bond C there. Okay, which is alkene. Okay, so the name will be wood. Okay, 4 carbon, wood. Then we state the position of the C double bond C, which is now it becomes a substituent. Okay, we call it 3. Okay, 3 because of this position. 3 in. Okay, and then the position of the OH 2 all. So wood 3 in 2 all. Okay, is the name. Okay, you can refer to the video of the workshop if you want to know the other name of it. Okay, I'm just going to discuss briefly about the answer. Okay, so next is C. Okay, which one will be the first carbon? Okay, we should start from the one that is nearest to the functional group OH. Okay, because OH now has the highest priority. Okay, so will be number 1 here, 2, 3, 4, 5, 6, 7. Okay, Cl is chloro. Okay, and we also have methyl at carbon number 6. Okay, so Cl will go first, alphabetical order. Okay, so the name will be 3-chloro 6-methyl. Okay, OH is at carbon number 3. 3-heptanol. I usually give name like this. Okay, but if you want to write 3-chloro 6-methyl hep 3 all, also correct. Okay, D. So which one will go first? Okay, if you refer to table of functional group A, okay, table group A in page 137, we will see that, okay, alcohol has higher priority compared to amine. Okay, so right here we have amine. Now it becomes substituent. We call it amino. Okay, so number 1 should be at the OH because this is the parent. Okay, this 1, 2, 3, 4. Okay, do not go 1, 2, 3, 4. Your amino will get number 4, which is wrong. Okay, the substituent must get the lowest number. Therefore, okay, for D, the name is 2-amino cyclobutanol. Now let's go to number 3, ketone. Okay, this is in page 144. Okay, ketones. Okay, so how to give name to ketones? Okay, let's give the number. Okay, the parent chain, it will be the one that has C double bond O. Okay, so the parent chain here, okay, this is carbon number 1, 2, 3, 4, 5, 6. Okay, so we have 6 carbon, it should be cyclohexanon. Okay, but remember you have the double bond at carbon number 3. Okay, starting at carbon number 3. Therefore, the name of this compound is cyclohex. Okay, not cyclohexanon yet, because you have to state the position of the double bond. So 3 in on. Okay, or cyclohex 3-enone. Okay, for B, we have OH, we have double bond O. Okay, according to table group A, double bond O becomes the highest priority. Therefore, OH here will be the substituent called hydroxy. Okay, so what is the name of B? Okay, give number first to the carbons. We have 1, 2, 3, 4 carbons. Okay, OH is at carbon number 2. Okay, and double bond is at carbon number 3. Okay, so what is the name? Okay, substituent first. So it will be 3-hydroxy. Okay, 3-hydroxy butan, and then, oh, I think I give the wrong numbering. Okay, sorry, very sorry. I will repeat again. Okay, so this is the hydroxy. Okay, this is the parent or the ketone. So number 1 should be here. Okay, 1, 2, 3, 4. Okay, so the name will be 3-hydroxy butan 2-on. Or, okay, maybe we can write like this, 3-hydroxy 2-butanol. Also correct. Okay, for C, okay, we have 3 functional groups. We have N. Okay, amines, and we have the C double bond C. We also have C double bond O. Okay, so C double bond O has the highest priority. So we give number 1 here. 2, 3, 4. Okay, 4 carbons only. Okay, and this is actually CH3. Okay, right up here actually we have CH2. Okay, how to give name? Okay, we have substituent in the substituent. Okay, what is the substituent in the substituent? Okay, firstly we have at carbon number 4. Okay, we have N substituent amino. Okay, amino here. Amino, because it cannot be amine because it is not apparent this time. Okay, so this substituent is amino. At the amino we have 2 methyl, CH3, CH3, methyl. Okay, so this is substituent in substituent. Okay, ataupun kita ada anak dia nama amino, nama cucu dia methyl dengan methyl, ada 2 cucu. Okay, so what is the name of this compound? Okay, remember our substituent amino, methyl, and the double bond pula guys tu. Okay, so what is the name? Okay, firstly we check. Okay, the double bond there is in. Okay, so that one will be at the back. Okay, so the first substituent that we have to give number is the amino. So it is amino attached to carbon number 4. So 4, and then we give name to the cucu first. Okay, it will be 4. Okay, the methyl is attached to N. Both attached to N. So 4 and N. Dimethyl amino. Close bracket. Okay, and then how many carbons that we have? 1, 2, 3, 4, and actually 5. Okay, we have 5 carbon. So pent. Okay, and then we state the position of the double bond. 4 in, and then the position of the ketone. Okay, 2 on. Okay, so another name may be 4 and dimethyl amino. 4 in 2 pentanone. But I don't think this one is suitable. Okay, just accept the first one. Okay, D. Okay, when you want to give number to the C double bond O, not the C double bond O is carbon number 1. Okay, it must be the carbon that is before the C double bond O. So this one will be number 1. Okay, 2, 3, 4. If you go down, it will be 5 and 6. If you go straight, also 5 and 6. So this is ethyl. This, okay, like that. Only one substituent. Okay, so the name will be for ethyl 6 carbons, hex 2 on, or 4 ethyl 2 hexanon. Okay.
Naming aldehyde is a bit special because aldehyde can only be at carbon number 1. So number 1 will generally be omitted from the name. So in a special case where the chain cannot include the carbon from the carbonyl group, the suffix carbaldehyde will be used. For example, here, this is the CHO. It is outside from the cyclohexane. So we cannot write cyclohexanal. That's wrong because carbon number 1 of the carbonyl is outside the ring. So we have to name cyclohexane carbaldehyde.
Okay, next is aldehydes. Okay, if it is a prefix, we call it oxo or formyl. Okay, if it is a suffix, we call it al. Okay, at the end of the name. Okay, so let's name the first one. Okay, the first one, put the numbering. Okay, C with double bond O will always become carbon number 1. So 1, 2, 3, 4. So 4 carbons. This is butanal. Okay, next. 1, 2, 3, 4, 5. 5 carbons in the longest carbon chain. And the substituent is methyl. Okay, so what is the name? Okay, we have 2-methyl pentanal. Pen is 5 carbons. No need to state the position of the C double bond OH, okay, because it will always become carbon number 1. Okay, if it has the highest priority. Okay, so in this question, okay, C, we have 1, 2, 3, 4, 5. Okay, we have methyl and ethyl as substituent. Okay, so the name will be 2-ethyl, okay, 2-ethyl 4-methyl pentanal. Okay, and lastly, here we have 1, 2, 3. Okay, so although the carbon in the ring is greater, which is 6 carbons compared to the straight chain, we still choose the straight chain as the parent because it has functional group with higher priority. Okay, so this will be propanal. Okay, so at carbon number 3 here, this will be the substituent called cyclohexyl. Okay, 6 carbons. So name for D will be, make sure you state the position of the carbon that attached to the cyclohexyl. So it is 3 cyclohexyl propanal.
Carboxylic acid also has a special case whereby if the carbon of the carboxyl group cannot be in the longest chain, for example, this molecule, as you can see, the carboxyl group is here, outside from the longest chain. This is the longest chain, cyclohexane. Okay, and carbon number 1 must be the one that is attached to the carboxyl group. Therefore, this would be number 2. Number 2 has 1 carbonyl group, and carbon number 4 has another one. So what we're going to write is 2-formyl 4-oxocyclohexane carboxylic acid, because carboxylic acid is not in the longest chain.
Okay, now carboxylic acids. Okay, if it is the prefix, we call it carboxy. Okay, but usually we will not have it as prefix. Okay, unless we have special case. Okay, and it always be the suffix called oic acid. Okay, so let's give the name. Okay, we have, okay, COOH is always carbon number 1. Okay, because it is the highest priority in group A. So 1, 2, 3, 4, 5. We have methyl at carbon number 2 and carbon number 4. Okay, so the name is 2,4-dimethyl. Okay, 5 carbons. Pentanoic acid. Make sure there is space between pentanoic and acid. Okay, for B, we have 2COOH now. Okay, it can be either one. Okay, for carbon number 1. Okay, but if you have substituent in the middle, so make sure the substituent get the lowest number. Okay, let's say I start from left. 1, 2, 3, 4, 5. Okay, still 5 carbons. Okay, so what is the name of this carboxylic acid? Okay, there are 2 ways to give the name. Okay, whether you start with pentan, and then the position of the COOH is at carbon number 1 and carbon number 5. Pentan 1,5-dioic acid. Dioic and acid space. Okay, or we can also give it as the name of it as 1,5. We put the numbers in front. 1,5 pentan dioic acid. Both are correct. Okay, for C, okay, as I said just now, priority goes to COOH, so it should be carbon number 1, 2, 3. The substitute that we have is amino, and this one is called phenol. Okay, I think if you watch the video of the workshop, you will know why this is not benzene, so I'm not going to explain anymore. Okay, so what is the name? We have amino at carbon number 2, phenol at carbon number 3. So for C, the name will be 2-amino, 3-phenyl, 3 carbons, propanoic acid. Okay, now let's go to D. Now we have COH outside the ring. So numbering cannot start here. Okay, we cannot put 1, 2, 3, 4. No, this is wrong. Okay, because ring, our ring is closed ring. Okay, it is not open. It is not an open ring. It is not a ring if it is open. Okay, so carbon number 1 should be here. Carbon number 2 where? Okay, always remember substituent must have the lowest number. So this is 2, 3, 4, 5, 6. Okay, so the name will be, okay, this is cyclohexane carboxylic acid. Okay, why the name is like that? You can refer to page 145. The one that has the menthol there. Okay, do you know? So read that. Okay, so the name will be, we start with bromo. Okay, bromo is at carbon number 4. 4 bromo, alphabetical order. 2 methyl. Okay, actually you need more space for the name. Okay, so it will be, I will write in this bracket. 4, actually no need to write bracket, yeah, for the name. Okay, 4 bromo, 2 methyl, cyclohexane carboxylic space acid. That's the name. 4 bromo, 2 methyl, cyclohexane carboxylic acid. Okay, cyclohexane and carboxylic acid, no space. Last one. Okay, this one will be carbon number 1, number 2, number 3, 4, 5, 6. So we have methyl as substituent. Okay, so what is the name? Okay, the name will be, okay, remember we have C double bond C also. Okay, so the name will be 5-methyl 3-hex, not hexanoic acid. Okay, remember we have double bond at carbon number 3, hexenoic acid. 5-methyl 3-hexenoic acid.
The next part is for us to be naming carboxylic acid derivatives, such as salts, anhydrides, esters, acyl halides, amides, and nitriles. Salts of carboxylic acid will be replaced by 8. So butanoic acid becomes butanoate. Cyclohexane carboxylic acid becomes cyclohexane carboxylate. For organic salts such as esters, the alkene name comes first, followed by the name of the carboxylate anion. So just remember alkyl alkanoate.
Okay, this is the naming for ester. So how to give name for ester? We must have alkyl alkanoate. Okay, alkanoate, you choose the longest carbon chain. Okay, so no, you choose the one that is together with the double bond O. Okay, after the C double bond O, that one will be the alkyl. So in this structure, okay, this is the methyl. Maybe I should write it as CH3. So this is the alkyl, okay, called methyl. Okay, so this will be the alkanoate part. Okay, look at the alkanoate part. Okay, we have a cyclic compound here, cyclic structure, ring, and we have OH attached to the ring. So you need to give numbers to the ring. Okay, so it will be 1, 2, 3, 4, 5, 6. Okay, so for practice 4.12, number 1, the name will be, okay, we state the alkyl first, methyl, and then space. Okay, and then we give name to the substituent in the substituent. So the substituent here is 3-hydroxy, which is the substituent for cyclopentil. Close bracket. Okay, and we have only one carbon right here in the alkanoate part, so we call it carboxylate. Okay, let's look at number 2. Number 2, okay, after the C double bond O will be the alkyl group. So this one is isopropyl. So this, all of this will be the alkanoate part. Okay, so we have here, you cannot give name here. This is the structure of the iso. Okay, we cannot give name right here, this one ester butyl. Okay, because okay, we need to have more substituent. The greater the number of substituent, okay, the greater the number of substituents, okay, the better the name. Okay, lagi banyak anak lagi bagus. Okay, so let's give the number. Okay, numbering for the alkanoate part. This one will be number 1, 2, 3. So we have 2 methyl here. Okay, methyl. So the name will be, okay, refer to number 2. The methyl, the alkyl part is isopropyl space. Okay, there are 2 methyls at carbon number 2. So we should give it as, the name as 2,2-dimethyl. Okay, so 3 carbons in the alkanoate part, propanoate. Okay, number 3. Okay, let's use different color. This part is the alkyl, which is called ethyl. We have 2 carbons. Okay, this part are the is the alkanoate part. Okay, how many carbon? 1, 2. Okay, so very simple. Number 3 is ethyl ethanoate. Okay, lastly, for number 4. Okay, for number 4, this part will be the alkyl group, which is cyclohexyl. Okay, and this part will be the alkanoate part. Okay, so now let's put the numbering 1, 2. Okay, and at carbon number 2 we have substituent called phenol. Okay, so what is the name? So for number 4, okay, the name is, we state the alkyl group first, cyclohexyl. Okay, and then the alkanoate part, the substituent first, 2-phenyl. Okay, 2 carbons only. ethanol.
Naming aromatic compounds or benzene is similar. First, we determine the root name of the parent, then we determine priority of the substituent and the position number. After that, we assemble the name in alphabetical order. Here, functional group priorities are also the same. These are the common ring system: benzene, naphthalene, anthracene. For mono-substituted benzene, it's not a problem where we can just put the substituent as parent: chlorobenzene, nitrobenzene, and ethylbenzene. Some common substituent will change the root name of the ring. For example, if you put carboxyl in benzene, you're going to get benzoic acid. Hydroxy group is going to become phenol, and OR group is going to become anisole. For di-substituted benzene, we're going to have two different substituent in one ring. So we can use common name auto, 1,2, meta, 1,3, and para, 1,4.
Okay, last video for naming. Okay, practice 4.13. Okay, this is for benzene or aromatic compounds. Okay, so how to give name? We give number first to the carbon. So this one should be number 1, 2, 3, 4, 5, 6. Okay, so for number 1, okay, number 1, oops. Okay, the name should be, we can give the name as 1,2 dibromobenzene, or okay, 1,2 position is ortho, O dibromobenzene. Okay, O is ortho. Okay, number 2. Okay, give the numbers first. 1, 2, 3, 4, 5, 6. Okay, make sure the substituents get the lowest number. So this is amino. So the name will be 3-amino benzoic acid. Why benzoic acid? Because all of this is called benzoic acid. Okay, you can refer to page 148. Special name for the common substituent that change the root name of the benzene ring. Okay, next we have number 3. Okay, we give number first. Okay, make sure you know which one has the highest priority. Okay, it should be the aldehyde. Okay, this one is H right here, so it is an aldehyde. Okay, so the aldehyde here will be called benzaldehyde. Okay, also refer to page 148. Okay, so this is methoxy. So the name will be, okay, numbering 1, 2, 3, 4, 5, 6. 2-methoxy benzaldehyde. Okay, just now I forgot to explain to you that this can be amino benzoic acid also. 2-methoxy benzaldehyde can become O-methoxy benzaldehyde. Okay, and for number 4, this one is called phenol. Okay, also refer to page 148. So this is methyl. So number 4, the name will be 1, 2, 3, 4, 5, 6. Okay, it will be trimethyl phenol or M-methyl phenol. No space between methyl and phenol. Okay, and last one, polysubstituted benzene. You cannot use orthometapara here when you have more than 2 substituents. Okay, so let's look at this structure. What is the name? Okay, this is called aniline. Okay, aniline. So for 4.14, number 1, where should I write it? Okay, 4.4, number 1. Okay, we have, okay, right here we have methyl CH3. Okay, and then we have numbering 1, 2, 3, 4, 5, 6. Okay, so Cl, there are 2 Cl at carbon number 3 and carbon number 4. Okay, so how to give name? Okay, it will be three, 4 dichloro. Okay, why chloro goes first? Okay, why chloro? Because we choose C, alphabetical order. So it will not be the methyl first, although it has numbering N. Okay, so 3, 4 dichloro. And then numbering for CH3, methyl is N. N-methyl because it is attached to N. Okay, and the parent is aniline. Okay, also refer to page 148. Okay, and last one. Okay, let's give the number. Okay, I will take the parent as toluene. Okay, also refer to page 148. Okay, this is toluene or methyl benzene. Okay, so this is so if you choose toluene as the parent, this should be carbon number 1, number 2, number 3, number 4, number 5, number 6. So the name will be 2, 4, 6. Okay, 3Br means tribromo toluene. Or if you don't want to use toluene, you can name it as 2, 4, 6 tribromo methyl benzene. Also correct.
I hope this video would be sufficient enough for you to start doing tutorial chapter 4 part 2, naming all the structures and drawing all the structures that we have there. Thank you very much for paying attention. Assalamualaikum warahmatullahi wabarakatuh. Bye.